Hello and welcome to our Drive Academy. Previously on motion, we had defined the motion and the stationary point. After that, we had described the motion using the terminologies like the distance and the displacement, wherein the distance was a scalar quantity and the displacement a vector quantity. If you have not seen these videos, link is in the description box. In this video, we are going to learn how we can measure the rate of change of motion of a body. For that, consider an example. If there is a body A which covers a distance of say 200 km and the time taken was 4 hours. Another body B covers this same distance of 200 km but takes a time of 2 hours. Then we say that the body B is moving faster as compared to the body A. Another body C covers the distance of 200 km but takes a time of 5 hours. We say that the body C is moving slower as compared to the body A and the body B. So knowing the time taken, we can clearly tell whether the body is moving slower or the body is moving faster. But can we represent its magnitude? The body B is moving faster compared to the body A, but by how much? For that, we measure the distance traveled by the body in a unit time and the quantity referring to it what we call as the speed of the body. So speed of a body, mathematical description for that will be distance traveled upon the time taken. In symbolic notation, we can write it as V equals S upon T, where V is the speed of the body, S it is the distance traveled and T it is the time taken. As the units of speed and time are meter and second, the unit of speed will be meter per second. In case of vehicles, we particularly use the unit kilometer per hour, like the buses, trucks and trains. As the speed of a body does not give us any information about the direction of motion, it does not tell us in which direction the body is moving. So it is a scalar quantity. It can be positive, it can be zero, but it can never be negative. In addition to that, if a body covers equal distances in equal intervals of time, say a body covers 5 meter for the first second and 5 meter for the next second, 5 meter for the third second, 5 meter for the fourth second, so on and so forth. Then the speed of the body is known as uniform speed. In contrast to that, if the body covers unequal distances in equal intervals of time, say a body covers 5 meter for the first second, 10 meter for the next second, 20 meter for the third second, so on and so forth. Then the speed of the body is non-uniform speed or the variable speed. In most of the cases, when we look, body generally move with the non-uniform speed or the variable speed. So to measure the rate of change of such bodies, we introduce what we known as the average speed. Average speed of a body can be calculated by finding out the total distance traveled and the total time taken. In our case, when we said that the body A traveled a distance of 200 km and the time taken was 4 hours, then average speed of the body A will be 200 km upon 4 hours, which comes to be 50 km per hour. We already mentioned that the speed does not tell us the direction of the motion. So when we specify direction along with the speed, the quantity is known as the velocity of the body. So velocity of a body can be defined as speed in a particular direction or distance in a given direction per unit time. More specifically, we can represent it as velocity of a body is displacement upon time. The units of velocity will be same as that of the speed because the units of distance and the displacement are same, that is meter or kilometer, etc. Now velocity of a body can also be uniform, that is constant velocity, or it can be variable, that is non-uniform velocity. If a body covers equal distances in equal intervals of time, we said that the speed is uniform. Similarly, if the body covers equal displacements in equal intervals of time, then the velocity of the body is uniform velocity or the constant velocity. And if it covers unequal displacements in equal intervals of time, then its velocity is non-uniform or the variable velocity. In case of variable velocity, We also here find out the average velocity. Average velocity of a body can be found out by finding the initial velocity and the final velocity. And the arithmetic mean of these two velocities gives us the average velocity of the body. So average velocity of a body is initial velocity plus final velocity divided by the 2. When a body is moving uniformly along a straight line, its velocity is constant. The rate of change of velocity in that case will be 0. The rate of change of velocity is referred as the acceleration of the body. Acceleration can be positive, it can be negative, or it can be 0. If the velocity is constant, that is, velocity is not changing per unit time, then the acceleration will be 0. So acceleration of a body is the rate of change of velocity of a body in a unit time. Or acceleration of a body will be change in velocity divided by the time. Change in velocity will be initial velocity minus final velocity. Change in velocity is final velocity minus initial velocity. Acceleration will be final velocity minus initial velocity divided by the time taken. So acceleration of a body is the measure of change of velocity of a body in unit time. Final velocity of the body is represented by v and the initial velocity is represented by u. As the unit of velocity is meter per second and the difference of these two also gives us meter per second. It is also divided by the time. Therefore, the unit of acceleration will be meter per second, that is meter per second square. As acceleration is the difference of the velocities with time, where velocity was a vector quantity, therefore acceleration is also a vector quantity. If the change in velocities, that is final velocity and the initial velocity is same, then the acceleration will be 0. And if the final velocity is greater than the initial velocity, then acceleration will be positive and the direction of the acceleration will be along the direction of the velocity. And if the final velocity is less than the initial velocity, then acceleration will be negative. And the negative acceleration is the retardation of the body. If we throw a body upwards, the velocity of the body is decreasing continuously due to the force of gravity. And this acceleration, initial velocity is much greater than the final velocity. That is, it is the retardation. And when a body is falling freely under the action of gravity, then its final velocity is greater than the initial velocity and the acceleration will be positive. The acceleration of a body is uniform acceleration. When the velocity of the body moving in a straight line changes by equal amounts in equal intervals of time. That is, the velocity of the body is changing at a uniform rate. For example, the motion of a body falling freely under the gravity is the example of the uniform acceleration. And when the velocity of a body is changing at a non-uniform rate, then the acceleration is non-uniform acceleration. In next video, we are going to learn the graphical representation of the motion. So these were all the basic concepts for the motion, that is the speed, velocity and the acceleration.